Our first speaker today is Georgina Humphreys from the Worldwide Malaria Drug Resistance Network, and she's going to be presenting on behalf of her co-authors on the spatiotemporal modeling of the prevalence of p-falciparum drug resistance mutations in the DHPS gene across Africa. Thanks, George.
Great. Thank you very much, Patrick, for the introduction, and thank you so much for the opportunity of allowing me to share through the medium of voice. This is my third ASTMH year, but the first time that I've been given an oral slot, so I really appreciate not having to just stand in front of a poster this year, which is great. And I want to share with you some unpublished data that I've been working on with a project, particularly with Dr. Jennifer Flegg, who's a mathematical modeler who's based at the University of Melbourne in Australia, and she's done all of the modelling work that you'll see today. So it's about modelling the prevalence of drug-resistant marker, particularly one in the DHPS gene, and that's related to resistance to sulfadoxin. And why do we care about resistance to sulfadoxin? Well, as you'll know, hopefully it's not used anywhere anymore for the treatment of malaria. But it is used in the prevention strategies, such as IPTP in pregnant women, and in combination with amidiaquine for SMC in parts of West Africa. And the reason why we care about whether there's resistance to it is because I think there's growing and convincing evidence that the prevalence of the particular markers, these mutations associated with resistance, compromises the effectiveness of IPTP. And I have some unpublished data from Feiko Tequila and Annemiek van Eek, which I can talk about later if people are interested in, which clearly shows that as the prevalence of these markers increase, the effectiveness of IPTP decreases. And when you get to levels beyond 90% of the 540E prevalence, that really compromises perhaps using SP for IPTP. So once you're convinced that there's a purpose to collecting these prevalence marker information, we need to try and make sure that we have up-to-date maps and patterns of resistance of the marker prevalences. And for those of you that are just not as familiar with markers and the genes and all these different acronyms, I just thought I'd put up this great picture from Javier Ding and Tim Wells's Malaria Journal paper that just draws attention to the different drugs and the genes that have mutations within them that are associated with resistance to those drugs. So for the purpose of this talk, I'm talking about the DHPS gene, which is related to resistance to sulfadoxin, as I said, and those are the sort of top hitter markers that have been associated with resistance. And again, drawing attention, I'm just going to work on 540E for the rest of the presentation. So where do we get our data from? We squirrel away looking at the published literature, obviously, which is the accessible source of this kind of data, and we have particular set inclusion criteria, of course, and we take the data extracted from publications and put it in a standardized database. And for the modelling work, we also use, of course, data from our colleagues across the road in Oxford from the Malaria Atlas project, which informs the background transmission levels. So the database currently informs a live tool, which anyone can go to through our website, the WARN website, and it displays all of the data in the database by pins on a map, and you can filter for time that samples were collected or minimum sample sizes and so on. And you also have a filter on the left there, you can see, which shows the different markers. So if I just click on 540E, then that's how it colours the map. And you can see that there's sort of higher prevalence over in East Africa than West Africa. But what we wanted to do was take that database and colour in the map to make it a little bit more predictive into spaces where you don't have data informed by the data you do have. And that's where this model came in. So this is Jen's methods that she's used for her model. On the left-hand side, you see the inputs. This is the discrete data points in time and space, and that's the schema of the model she uses. And on the right-hand side, you see the outputs from the model. It's a Markov chain Monte Carlo algorithm, and as I mentioned, we use as a covariate the Malaria Atlas project estimates. And it predicts, because of the map granularity is 5 by 5 grid, so we match that and we predict on a 5 by 5 grid for each of the years between 1990 and 2018. And what it does is have a predicted distribution for each location, what we think the prevalence might be within that 5x5 grid point, and then you take the median, which is the bottom right-hand graph. You can see the red line represents the median of that probability distribution, and then the standard deviation around that, which is obviously important for uncertainty. So I think it'll be clearer, hopefully, to everyone when you see these maps. So just to talk you through, the left-hand side is obviously the map transmission estimates. The middle is the 540E prevalence estimate, so that median point. And then the right-hand side is the uncertainty. So the darker the red, the higher the level of uncertainty. And this is just a snapshot of the 1990 maps. And if I start the next slide, it will roll. So the maps will just roll for each year. So you'll see now the middle and the right-hand side rolling as the years go up on the top. And you can see the marker prevalence really expanding in East Africa as time goes on, and the transmission on the left obviously starting to pleasantly decrease. And then you can also see areas of real uncertainty where there's no or very little or no data at all. And then it runs right to 2018, but the caveat is obviously there's very little, very recent data, and then this just starts running again. So if I just take you to the 2018 picture so you can see what our latest prediction would look like. Obviously, there are areas, as I said, of very sparse data, particularly Central Africa, so we probably just don't know what the prevalence is like there. But there is a persistent high prevalence in East Africa. And if we go to the conclusions, hopefully I'm okay on time. So some areas have high uncertainty with, of course, the sparse data. Any model is only as good as the data that's informed into it, entered into it. And so we do definitely have areas where there's hardly any prevalence information that we can feed in. But I hope that you'll be convinced that there's clearly a different pattern in East and West Africa, and that we have pretty stable high prevalences of 540E in East Africa. And clearly over the 90% threshold, which is the area for concern for IPTP using SP, is clearly present in parts of East Africa. So what do we want to do next? Of course, more data is always useful. Even one extra data point for a model like this is beneficial. So I do have a plea for anyone in the room or anyone you know that might have this kind of data, if they would please be encouraged to share it for all of us, because I should have mentioned that the database is fully downloadable from our website for anyone to use and reuse for any purpose. And so this is all about informing the picture for everyone to use. And maybe we'll also add in some of the other markers of interest. And what would be great also is with FICO and Annemiek's help to think about integrating some of the collected effectiveness data from IPTP. So there's just to emphasize that we have multiple surveyors available. So we also collect marker information on artemisinin, the K13 markers, and also on ACT partner drugs. And again, all of those databases are fully accessible to anyone to click and download whenever they want from the website. So just to acknowledge my great colleagues, of course, this isn't work just done by me. Jennifer Flegg, I've already mentioned, and the database that we inherited from Callie Roper's group at the London School is also used to inform this model. And I want to highlight Sabina Otienoburu's poster on Wednesday, which is on the ACT partner drug surveyor. So that'd be great if you could go and chat to her too, and our colleagues from Liverpool School, as I've mentioned. And I welcome any questions. Thank you so much for your patience.
Thanks, Georgina. We do have time for a few questions, so if you step to the microphone, identify yourself and be brief, please.
Timo Kleinschmidt, London School of Hygiene and Tropical Medicine. Could you tell us whether there was a relationship between marker prevalence and infection prevalence, because you had that in your model?
No, that's not. I don't have an answer to that. We use the transmission estimate as a covariate, but I don't know the association. We didn't test it an association between the transmission level and marker prevalence. No, we haven't done that. But that's a good point. Thanks.
Any others? Well, with that, thank you, George. If you have questions, please follow up directly with her following the session.